Hidden beneath the ice-cold, uncharted depths of the Arctic Ocean lies one of the least understood and potentially most dangerous volcanic systems on Earth, the Gakkel Ridge. Unlike the famous supervolcanoes of Yellowstone or Toba, this enigmatic volcanic region lurks in the abyss, shrouded in darkness, largely ignored due to its remote location. But what if this deep-sea behemoth is far more active than we ever imagined? For decades, scientists believed that the Gakkel Ridge, a slow-spreading mid-ocean ridge, was relatively dormant. However, startling discoveries in recent years have unveiled signs of an active and dynamic system beneath the Arctic ice. Some researchers now question whether the ridge harbors a hidden supervolcano, capable of producing a catastrophic eruption. Furthermore, there is growing concern about the shifting magnetic North Pole, which is moving directly toward the Gakkel Ridge. Scientists warn that these geomagnetic changes could increase pressure on the already unstable volcanic system. Today, let's delve into the fascinating mysteries of the Gakkel Ridge, its geological secrets, its potential for a major eruption, and the consequences that such an event could have on the planet. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Gakkel Ridge stretches approximately 1,800 kilometers from Greenland to Siberia, making it one of the most isolated and least studied parts of the global mid-ocean ridge system. It is the slowest spreading ridge on Earth, with a rate of about 6 to 13 millimeters per year. This slow spreading rate was traditionally thought to result in limited volcanic activity, but recent discoveries have challenged that assumption. Unlike fast-spreading ridges, where magma supply is continuous and eruptions occur frequently, slow-spreading ridges like the Gakkel Ridge were assumed to produce less volcanism. However, recent expeditions have found extensive volcanic structures and hydrothermal vents along the ridge, indicating that significant magmatic activity is taking place beneath the Arctic ice. The ridge is characterized by deep valleys and faulted terrain, indicating strong tectonic activity despite its slow spreading rate. Seafloor mapping and seismic studies have identified numerous volcanic structures, some of which resemble calderas found in large volcanic systems on land. Additionally, hydrothermal vent fields have been discovered along the ridge, suggesting that magma chambers exist beneath the seafloor. One of the most significant discoveries was made in 1999, when a series of earthquakes in the magnitude 4 to 6 range were detected along the ridge. This seismic activity led to the hypothesis that a large-scale volcanic eruption had occurred. Subsequent surveys confirmed the presence of fresh lava flows, suggesting that eruptions had taken place in recent geological history. The discovery of fresh volcanic material along the Gakkel Ridge challenged previous assumptions about its inactivity. Rock samples collected from the seafloor contained high concentrations of volcanic glass, indicating that eruptions had occurred relatively recently. Additionally, chemical analyses revealed that the lava was rich in volatile elements, suggesting that the magma beneath the ridge contains significant amounts of dissolved gases. In 2001, a major expedition led by the Arctic Mid-Ocean Ridge Expedition discovered evidence of explosive volcanic activity. Scientists were surprised to find large pyroclastic deposits on the seafloor, indicating that some of the eruptions along the ridge had been highly explosive. This finding was particularly unexpected because most mid-ocean ridge volcanoes produce effusive basaltic lava flows rather than explosive eruptions. The presence of pyroclastic deposits suggests that large amounts of gas were trapped within the magma, leading to sudden and violent eruptions when the pressure was released. This discovery raised new questions about the potential for future explosive eruptions along the Gakkel Ridge. The term supervolcano is typically reserved for massive volcanic systems capable of producing eruptions exceeding a magnitude of 8 on the Volcanic Explosivity Index. Examples include Yellowstone in the United States and Toba in Indonesia. These volcanoes have large, long-lived magma chambers and can produce global climatic effects when they erupt. While the Gakkel Ridge is not typically classified as a supervolcano in the traditional sense, some researchers argue that it has the potential to produce significant eruptions. The presence of large caldera-like structures on the seafloor suggests that major magma chambers exist beneath the ridge. If one of these chambers were to experience a sudden release of pressure, it could lead to an unusually large submarine eruption. Although the Gakkel Ridge has shown evidence of past eruptions, predicting future activity is challenging. Most of the world's major volcanic monitoring systems are located on land or in more accessible oceanic regions, making it difficult to study the Gakkel Ridge in real time. However, there are several factors that suggest the ridge could be capable of producing a significant eruption. The presence of magma increases the likelihood of explosive eruptions. The volcanic glass samples from the ridge indicate that gas-rich magma is present beneath the seafloor. The ridge is located in an area of ongoing tectonic movement, which could contribute to magma accumulation over time. Seismic activity along the ridge suggests that stress is building up in the crust. The discovery of hydrothermal vents indicates that heat and magma are actively circulating beneath the seafloor. These systems are often associated with volcanic eruptions. While the exact likelihood of a major eruption is uncertain, the presence of these factors suggests that the Gakkel Ridge should not be ignored as a potential source of future volcanic activity. One of the most intriguing and potentially alarming geological phenomena of recent decades is the rapid movement of the magnetic North Pole, which has been shifting from Canada towards Siberia, directly in the direction of the Gakkel Ridge. This movement, occurring at an unprecedented rate of about 50 kilometers per year, has puzzled scientists and raised questions about its potential consequences for Earth's geology, including the possibility of influencing volcanic activity. The Earth's magnetic field is generated by the movement of molten iron within the outer core, which in turn interacts with the planet's lithosphere and deep magma systems. Some researchers speculate that changes in the magnetic field could alter the balance of forces acting on magma reservoirs, particularly in geologically sensitive regions such as mid-ocean ridges. The Gakkel Ridge, already showing evidence of volcanic activity, lies in the direct path of the migrating magnetic pole, making it a prime candidate for increased geophysical stress. Although no direct correlation between magnetic pole shifts and volcanic eruptions has been scientifically proven, some theorists argue that sudden geomagnetic changes could disrupt existing magma chambers by altering electromagnetic currents and thermal convection patterns deep within the mantle. If the movement of the magnetic North Pole is exerting additional stress on the already volatile system beneath the Gakkel Ridge, it might contribute to an eventual eruption. While this hypothesis remains speculative, it underscores the need for further research into the interactions between Earth's magnetic field and deep-sea volcanism. If the movement of the magnetic North Pole does play a role in geophysical disturbances, the Gakkel Ridge could become a ticking time bomb, with consequences that extend far beyond the Arctic Ocean. If a major eruption were to occur at the Gakkel Ridge, the consequences would depend on the scale of the eruption and the amount of gas released. Large-scale volcanic eruptions release significant amounts of sulfur dioxide and other gases into the ocean. These gases can lead to acidification, which can have harmful effects on marine ecosystems, particularly in the already fragile Arctic environment. If an eruption were large enough to release significant amounts of sulfur dioxide into the stratosphere, it could lead to short-term global cooling. Historical eruptions, such as the 1991 eruption of Mount Pinatubo, have demonstrated how volcanic aerosols can temporarily lower global temperatures. An undersea eruption could produce significant amounts of heat, leading to localized melting of Arctic ice. While the overall impact on global ice levels would likely be small, it could disrupt ecosystems that depend on stable ice conditions. Also, the possibility of a tsunami cannot be ruled out. If a major eruption triggered an underwater landslide, it could generate a tsunami that might affect coastal regions of the Arctic. Given the potential risks, further research and monitoring of the Gakkel Ridge are essential. Advances in deep-sea exploration technology, including autonomous underwater vehicles and satellite-based monitoring systems, may help scientists gain a better understanding of this hidden volcanic system. Until then, the Gakkel Ridge remains one of the most intriguing and potentially hazardous volcanic regions on our planet. What do you think? Could the next major volcanic eruption come from the deep Arctic? Let us know your thoughts in the comments section. Thanks for watching, and see you in the next video.